The main objective of Perform would be to provide a sustainable alternative to certain chemical processes, to chemical industry in general. One way we can do this is by using a different feedstock. In case of Perform, we switch to a bio-based feedstock. So we take away the fossil-based feedstock in classical or conventional chemical industry, and we replace it by a bio-based feedstock. And on the other hand, we're also focusing on electrification. So electrifying the process, converting the bio-based feedstock in an electrochemical process to the desired components. VITO's role in this project is mainly on the development and demonstration of one specific reaction. And this reaction is the conversion of glucose to glucaric acid and finally to adipic acid. Adipic acid is a compound which is readily used in chemical industry and mainly in polymer industry for the synthesis of nylon 6,6, a very common polymer. And what VITO actually focuses on is first the oxidation of glucose to glucaric acid, and in the subsequent step we will develop also the reduction of glucaric acid to adipic acid, the desired component basically. So we will develop the reaction, the electrochemical reaction in this process, but we will also focus on the DSP, the downstream processing so-called, which is the separation and the purification of the component that we form. Gluconic acid and glucaric acid are formed in our reactor and are separated by a process called electrodialysis. Electrodialysis actually selectively takes out glucaric acid and gluconic acid from our reaction mixture, and that's what we further will use for the separation and for the purification. This concentrate of gluconic and glucaric acid will then be transformed to a cooling crystallizer, and there we will drop the temperature, limiting the solubility of the glucaric acid and therefore creating also precipitates and pure glucaric acid crystals. To further increase the separation efficiency, we add another anti-solvent, we call it. Actually, it's a solvent that is used to lower the solubility of the glucaric acid in this mixture, which further increases the productivity of this separation. All these crystals can then be collected from the different process steps, and they can be further purified by using this anti-solvent to wash them. And all the washing water, all the washing liquid basically, which contains water but also the anti-solvent, can be recovered by distillation in a subsequent step. So the main benefits of the Perform process are twofold. On the one hand, we use a carbon neutral feedstock, glucose, for example, derived from cellulose. And on the other hand, we can plug in our process into the renewable energy grids. So organic electrochemistry is still quite young. During the past 5 years, very promising results have been shown in literature as well. Upscaling is quite new and still many hurdles need to be taken, but the prospects of developing a sustainable and carbon neutral process to the existing fossil-based route is very rewarding and should be really explored further.
And it's very important for industry and for academic world is how to convert selectively glucose to glucaric acid. And it's a very challenging project.